All right. So in the generative way, so I think most of you, anybody is missing from the previous classes. How many of you are new? The Krishna, one, two, three. I feel except two or three, everybody is new here. All right. Fine. I'll just give the first 10 minutes as a demo. Right. Yes. So let's start. So in this course, I'm going to cover these following topics. So the first thing is the Python for the AI and data science, where I'm expecting the little bit fundamental knowledge about the Python, like how to write the loops, how to make a variables, etc. I will be taking care from the Python for the data science, where we will start from the NumPy, so numerical Python, how to create the arrays from the for the AI, so which we call the NumPy library, and then we will use the pandas. Pandas will helpful to read the CSV files, the TXT files, and it is like the tabular data you can read using the pandas, and you can do all the operations whichever is possible using the SQLs. Then we do the data visualizations, plotting the different the features from the existing data using the matplotlib and cbar. So this is for the Python for AI and data science. Then once we complete this Python fundamentals for the AI, we'll go ahead learn about the natural language processing. Natural language is nothing but the language which I'm speaking right now, the English, Telugu, Kannada, Hindi. So all these languages we call the natural language. Because in the generative AI space, you take the ChatGPT or Gemini or Grok, any model. So the input is a text. So you should know how to process the text, how to analyze the text. Like first you understand the meaning of text and then split the sentence word to word and create a numbers out of it, understand the grammar of a sentence. These are all part of the natural language processing. So in that we have the three processing techniques: lexical processing, the syntactical processing, semantical processing. Lexical processing is nothing but understanding word to word. Syntactical is nothing but understand the grammar. Semantic is understand the meaning of a text. And once we are done, we can build a couple of projects on top of whatever we are learning. Each concept will have the theory and practical session. And once we are more confident on the natural language processing, we'll go and learn the deep learning. So here, we will try to create a network, a neural network. So neural network is like replica of a human brain. So we have the human brain neurons, right? So we will try to make a replica of that in the computers. We call it as a perceptron. Each neuron from the neurons in the human brain, we call it as a perceptron. So arrange the neurons in a particular order and layers, it becomes a neural network. Okay, so to understand neural network, you have to know the feed forward propagation, backward propagation, activation functions. Functions are nothing but suppose once you look into some particular object, your brain will fire some neurons, right? That will make you recognize that particular object is a cat or dog or tree. So those we have to replicate within the deep learning. We call it as activation functions. And then there are algorithms will be there within that, especially gradient descent algorithms. And then so if it is a text, the text will have the sequence of words. Then we have to go for a little bit advanced neural networks. We call it the recurrent neural networks, and we'll discuss about the problems and the architectures behind it. And there is more advanced versions of the RNNs, which we call the LSTMs and GRUs. And we will discuss about the frameworks, the TensorFlow, the Keras, and the word embedding technologies and the logic behind it. Some of you may be very new to this one. It is fine. This is a beginner friendly course so that anybody can follow up. And then we will go for the transformers. The transformers is key for the generative AI models like LLMs, whatever we have. So if you remember the GPT, ChatGPT, what is the GPT? The full form of the GPT is Generative Pre-trained Transformers. Okay, so the transformers concept came from there. So transformers came from the paper published by the Google in the 2017. That is the fundamental for the currently whatever we are learning as generative AI. So we have to understand the architecture behind it. So which is the part of the course also. So we will try to understand the papers published by the Google to dig deeper into the transformers architecture. So that paper is attention is all you need. So this is the paper published in the 2017 by the Google. So we'll try to understand this entire paper, the architecture of the transformers, and we will build the models, not just the theory. We'll build the models. So we'll take the GPT-2 model, train with our own data. So we have the resources. We need to have the GPU resources to train on it. So I will tell you how to use it for free also. Some of you may not be having the computers to train it, right? You can use the Google Colab for free. And once the transform is completed, we'll go with the large language models. We discuss about all the LLMs, try to build the chartboards out of it. And we try to deploy our own models using the Olama and a little bit of prompt engineering. And then once the large language model is completed, we'll go and dig deeper into LangChain and Hugging Face framework. So this framework will helpful for us to build a production grade applications. So we're just using the LLMs, we can't build the production grade because production requires you to have the databases and the agentic workflows and the knowledge base retrievals, which we call the retrieval augmented generation RAG portion and deployment. So everything is possible within the LangChain ecosystem. And then we try to understand the RAG system. So where we will build the projects with the couple of chartboards which can help us to chart with the PDF or database or search engines, and a few of the tools, agentic tools, we'll try to discuss. And we'll have the projects for each and every module. Okay, this is like oral view. So some of you may feel like completely jargon words, but that is fine. Over a period of time, you will be comfortable with understanding all these concepts. And we will build the UIs. UI is nothing but supposed to build the chartboard. You need to have the UI knowledge, right? HTML, CSS, not required to have that. So in general, we use the Streamlit and Gradio. These two frameworks will help us to build the UIs also using the Python itself. No need to have the JavaScript, HTML, React kind of a frameworks. Yeah, this is my complete course. It will take eventually around 2.5 to the 3 months of the time uh, to complete it. Right. So let's start our first class. So the first class about first where do we write the code? Where do we write the code? So everybody knows it's a Python. So we need some development environment. So that we have to download it first. That you can download using Anaconda. Anaconda is our distributor. So where you just go there, get started. Uh, Just free download is option is there, right? Click on this free download option. So it will download the Anaconda distribution into your computer. Just double click on it and everything you just follow with the next steps and you know how to install a package, right? So once you are done with the Anaconda installation, it comes with lot of inside tools. Among them, so we will use the tool, the Jupyter Notebook. Let me open. Yeah. This is how it will open. You just once you're done with the installation, in the search bar, Windows search bar, type the Anaconda. There is Anaconda Navigator option will come. You just click on it. You will see all these tools. So it is having the reason for using the Anaconda is you can have the flexibility to use the multiple environments. So what is the environment? You may be working on the in the real time in the company. You will have the multiple projects. You may be working on some person is working the chatbot, the other person is working the data science, the other person working on the image based models. So you should not make confusion between the multiple projects. So you can create the environments and each environment is dedicated to one particular project. That organization is possible within the Anaconda. That is a major thing. And the creation of the environments is very easy. And then you can install the packages very easily. So everything package management will happen within the community. So among this, so I'm looking for the IDE where I can write the code. That is a Jupyter notebook. So though we have the VS Code, Jupyter Lab, PyCharm, and Spider, these and all also available. If you are comfortable with this thing, you can even go with that. But I wouldn't prefer that. The reason is we need to look the inline plots. Suppose you wanted to run the code line by line and check the output from each and every cell. That is only possible with the Jupyter Lab or Notebook. Any one of them is fine. Either you can choose the Jupyter Lab or you can choose the Notebook. I'm going to choose the Notebook. Click on the launch. So it will launch the application. So you can see it is going into my C drive by default. For example, you wanted to run it in a D drive. So everybody is having the multiple drives in their computer, right? C drive, D drive, E drive. You wanted to run from the D drive, the code will be a little bit different. So you have to run through the command line. Go and search in the bar Anaconda prompt. So, and it will open this command line tool. I'm sorry, I'm sharing the screen. Yes, everybody is able to see my screen, right? Somebody is asking, are you not able to see my screen? Yes, right? Yeah, everybody is able to see the screen. Whoever is not able to see the screen, just click on that. I think you are joining from the mobile. Maybe the somewhere the screen will be there. You just need to see where it is. All right. So look at here. I am in the C drive. When I click on this Windows search bar, you will see the Anaconda prompt. So you will see this command line tool. So if you wanted to go to the D drive, click on the D, and you type the Jupyter notebook over here. Just enter, and it will run, and it will open directly within your the Chrome browser. You can see it started, and you can see my D drive. Earlier was C drive. So from here, all the D drive folders and the files you can see here, right? Yeah. So this is the thing. So now, so we got to know how to use the Jupyter notebook and just clicking on it, so it will open it. So now let us see the notebook, how we can create. So go here, there is a new button, click on the new. So you can see the Python 3 IPY kernel. Okay, so it will open the Python notebook. Click on this button. It will go to the next page where you can see the Jupyter notebook UI. Here you can write the code. You just name the notebook, maybe the sample test notebook. And here I can write the code. My first code is like the print welcome to data science, welcome to generative AI course. Okay, this is the Python syntax to print the statement. So you locate the all the cells, whatever is present. Click on the run, it will execute the particular cell. Right? Whatever the code present in this cell will be getting executed. Suppose if you wanted to write multiple lines, suppose I wanted to see the 2 plus 2, it will give you the 4. Okay. So this button will help to run the cell, and you wanted to create a new cell. There is a plus button, click on it, it will create a new cell. So every cell is a coding cell. Suppose you don't want it to use it for the cell for the coding, but you wanted to write some context like the So this is about Python. Okay, it's my comment. So when you start with the hash, it is a comment, right? So instead of writing as a comment, you can convert this particular cell into the markdown. Now it is the text heading 1. You remember the Word document. Word document will have the heading 1, heading 2, and heading 3. Like that you can create. Even you can write whatever you want. The description. Suppose you wrote this code, you wanted to add some context to that. Let us say what this code is about and all etc. information you can write within the markdown cell. And there is a one more option. Suppose this entire code was there, you wanted to comment it out. You can use the hash, it will comment it out. Or the other option is change it to the raw. When you change it to the raw NB word, it will not execute. You will run 100 times, it will not get executed. The code cell is dead. This entire cell is dead, it will not get executed. Right? So these three cells are popular, which we will be using in entire the course. And you wanted to move this cell up and down, you can use this arrow symbols to move the cell to anywhere you like. You wanted to cut the cell, click the cut, and you can paste also. And this save button, and you can stop this entire kernel to be running. You can click on the stop. The program will interrupt. Suppose you're running a code, you wanted to stop the program, you just click on that cell and click on the stop, then it will interrupt the kernel. Suppose in case of some emergency and your kernel got stuck somewhere, you had to restart the kernel. So the kernel is nothing but this entire Python notebook. For the restart, click on the kernel, restart kernel, restart button is there. So it will ask you to pop up, so restart. So whatever the programs it is running, it will stop all of them and restart your notebook. These uh, things we will use in day-to-day life. You got it? Right. So as part of our the first one, we will discuss about the arrays. So today, the arrays concept is very popular in the generative AI. So without these NumPy arrays, we can't proceed. So every single model, the input has to be passed through this only, the NumPy array. So let me create a new notebook. I will write over there. Everybody is clear about the notebook? You just try it out after this class. You should be able to, by the next class, you should be ready with all this Jupyter notebook and all, so that it is easy for you to follow up. So let's talk about the basics of the NumPy. I just renamed my notebook. So what is the NumPy? First, you have to install the NumPy. So how to install the packages within the Python environment? So how, if you are coming from the Java background, there is a Maven repository, if you remember. The Maven that will help you to download the jar files, right? And Maven repository will be there where you can compile it and everything you can do. Similarly, we have in the Python pip. Pip install NumPy. Just type this one, it will give you the website. The website name is pypy.org. So here you can search for any project. You want the pandas, click for the pandas. Okay, so it will give you the pandas. So how to install the pandas? Pip install pandas. For example, you wanted to install the NumPy. So click on here, pip install NumPy. Just copy this and execute. Execute this cell. So it should be coding cell. So once you execute by clicking on the run, or the other shortcut was control with enter. Hold the control and press the enter instead of going and clicking on the run cell. Since it is already installed, so I'm not going to install it right now. So let it be there. So you can see the requirement is already satisfied, means the package is already installed. So you wanted to clear this output, whatever is being displayed, that you can do by the edit, the clear cell output. Mouse cell, the view, copy cells, clear cell output. Right. So I think they changed the version because this version is not having, generally it used to be in edit. Edit, you will see the clear cell output. So if you're not seeing here, you can even do from here, but depending on the version which you have downloaded in the Anaconda, that will vary. But generally, you must check in the edit. Here you should be able to see clear cell output. If it is not here, go to the cell and clear the output. And just for your, to make your notebook very clean. So no need to show the outputs directly to the user. So now once you are done with the installation of the NumPy, so let us use it. Import the NumPy. So import NumPy as NP. Import NumPy. So instead of typing NumPy all the time, suppose you can even do the import NumPy and then create an array. Array is nothing but bunch of numbers, right? So I can create NumPy dot array and pass all the elements. Suppose I wanted to create an array with 5 elements, the list of 5 elements. Okay, so it gets created every time. Instead of typing the numpy, I'll just give it an aliasing name as a np. So I don't need to call every time the numpy. I just call it as np dot array with all the elements, right? So this way I can import the numpy and I can use it to create the arrays. Right, so we have created a very simple array. So it's a one-dimensional array. So why I'm calling it a one-dimensional? Because it is a single list. Suppose if you keep the list inside a list, the list of elements or array inside an array, we call it as a two-dimensional. This is one-dimensional array, array with one-dimensional. So let me create even two-dimensional one. np.array with 1 comma 2 comma 3 is inside my array and 4 comma 5 comma 6. Now you can see the array inside an array, right? It's a measure array. The outside one is a measure array. Inside that you can see the two arrays. Array inside an array. It's called two-dimensional array. So can you see here? It is looking like a matrix, right? Matrix with the rows and the columns. Two rows and the three columns were present. So two-dimensional array is nothing but a simple matrix. So can we create a three-dimensional in such a way? You can do that, right? Three-dimensional. How to create a three-dimensional array? np dot array inside an array, inside an array. Three levels of the nested loops. So here the two levels, and you can see here the three levels. Here I will write again. Uh, so array, inside an array, inside an array. So three. So you can remember by looking at these braces. If it is starting with the three braces and ending with the three braces, you can call it as a those many dimensional array. If it's starting with three braces, it's a three dimensional array. If it's starting with the two braces, you can call it a two dimensional array. So here you can see it's a three, starting with three, you can call it a three dimensional array. So just print it. Okay, so you can create n number of dimensions by just calling it, right? So now I'll create some arrays with some dummy values, and I will try to do some operations. Is it clear? Any doubts so far? Any problems? All right. Let me create an array with some given dimension. Suppose a two-dimensional array I will take. I wanted to create 2 by 4. 2 by 4. 2 rows and the 4 columns. 2 rows and the 4 columns is nothing but 2 by 4. So I will create using the ones. What should be the values within the 2 by 4? So in this case, I will use the ones. np.ones, this function will give me all the ones with a given dimensionality. The 2 by 4, I want all the values within that array to be 1. So 2 rows and 4 columns, all the values will be the 1. Same thing, if you want with the zeros, you can have the zeros function. But what if you want the random values? Initially, you want to define with the random values. So these are all basics for the next classes. Okay, so once the basics completed, we will I will directly tell you how to use it and where we can use. So this random function will helpful for us to create the random numbers within that array. Same 2 by 4 matrix. Here I'm using the ones to create with ones. Here using zeros to create with zeros. Here I'm using random to create with the random values. What if I wanted to create with an array from 10, 15, 20, 25, 30 till 100?
Why did we write random two times?
Yeah, that is how it is. This initially, so generally you're expecting to have only the random, right? So in this case, the code, how they have implemented is they have put the one function inside another function. This we have not implemented. This was developed by the NumPy people. Since it is open source, so ideally it's supposed to be, it's always better to have the outside random, but because it's a community based, right? Python is a community based library. So whoever contribute to it, even you can contribute or I can contribute. So that is a problem because people will not follow the proper guidelines when they are developing it. In case of the Java, there is an architect, they will decide how the functions to be decided and all. But the Python, it's open source. So people will just write the code however they want and contribute to the modules. In that way, you will see such kind of a discrepancies. Okay, random dot random. So they put, instead of directly putting the random function outside, so they created the two random functions within that. So yeah. So to know what is there, we have to read the documentation anyway. So the documentation for the NumPy is available within this the numpy.org website. So here we are going to use numpy.random. It is having nearly these many functionalities. Look at here. So numpy.random is having the random state and the, where is that? Uh, the binomial and the random. In that, because it's about the mathematics, NumPy basically designed for the mathematical functions, the logistic Laplace transformation and the geometric operations and everything. So our function is somewhere here, numpy.random.random. Because outside this numpy.random, it is having the multiple functions, the power, poison, and all. In that, we are going to use the random again. It's just we just need to go through the documentation, then only we'll come to know how to use it. All right. So this code and all, so definitely it will be available in the documentation. You just need to read all of it. So instead of you going through that, I did all the job. So I just found it how to do it so that you can save the time. So it's always good to have simple random, but unfortunately they didn't do it. Now how to create the numbers which are having the linearly separated by the number 5. 10, 15, 20, 25 till 100. So we can see the consistently the 5 as a gap, right? Can I generate these many numbers? Is there any function? And NumPy is having a range function. Range function, you mentioned the starting and ending and how much increment you wanted to do for every number, 5. Start with the 10, increment by 5, it will become 15, again increment by 5, it will become 20 until it reaches the 100. Okay, starting, ending and incremental. Starting 10, ending 100, increment each and every number by 5. But it will not give you 100. Why it will not give you the 100? The reason is this ending is always exclusive. If you mention 100, the NumPy will take till 99 only. Then to take 100, what you had to do? You had to take 1 at 1 plus 1. What? Then it will take till 100. So that is a catch here. So ending always exclusive. So always add plus 1 to the ending. Then it will reach to the number whatever you are looking for. Now, what if I want the numbers from 15 to 18? I want total 25 numbers in between the 15 to 18. Generally, how many numbers are possible between the 15 to 18? How many numbers are there between the 15 to 18?
Two numbers.
15 to 18?
Numbers 15.00001. It can go on, right?
Mm. Infinite numbers, right? Infinite numbers are
Yeah.
possible between the 15 to 18.
Yeah.
So I'm just looking for 25 on that. So then the 15. So you segregate all of them into the same interval. So 15 to 18 is having how many numbers? Total 15, 16, 17, 18. Total 3 numbers are there, right? Total 3. I am looking for total 25 numbers in that. So see that. NP dot the linear space function and starting with a 15, ending with a 18. Total I want 25 in between them. So 15, 15.125, 15.25, interval is same. Interval is 0.125, right? 15 plus 0.125 is 15.125. 15.125 plus 0.125 is 15.25. So equally distributed. So the interval is same, 0.125. So that will take care of the how to separate and how many intervals they had. It will take a linear space function. Right. So let me create one random matrix np dot random dot random. I will create 6 by 4 matrix. This is my array 1. It's not one dimensional, just array 1. I'm mentioning array 1. We got 6 by 4. What is the data type for each and every number, each and every value present in this matrix? Is it an integer or float? So that you can define or you can get the values by d type. You just call the d type on top of the array 1. It will give you what data type is present within this matrix. So each and every value is a float. My operating system is 64-bit. That's why it is a float 64. And you wanted to get the shape of this matrix. 6 by 4, you get it. And what is the dimensionality? You know, right? Two squared braces it's starting with and ending with two squared braces. It's like two-dimensional array. So that information also you can get by n-dim. So it is giving you the number of dimensions. And how many values are present in the 6 by 4? Total 24, right? 6 and 4. 6 multiplied with 4 is 24. Total 24 values are there. Size. Total 24. And how much size each element is having. How many bytes of memory is being taken by each and every value. That also you can get by item size. So each and every value has been taken 8 bytes of memory. Now if I ask you a question, total memory taken by this complete matrix is how much? How much memory is taken by this complete matrix? You know, each value is considering like 8 bytes and total 24 are there. What is the total memory taken by the entire
24
matrix?
bytes. Yeah.
Yeah, you multiply, right? Multiply the
Yeah.
item size with the size. 24 multiplied with 8. So it will give you the 192 bytes. So what else we can do? What else we can do with this arrays? So you can create the arrays. So what if I have the array, let us say I have created an array with np dot range with a 0 to 24. Total how many elements will be there? 25, including the 0. The 24, I'm sorry. Total 24 elements will there, including the 0.
It was 23, not 24.
What, 3?
Yeah. I thought the total numbers will be values will be 23, right? If
Yeah,
it's
including
24,
0.
it's easy.
Correct. Total values will be 23, but including the 0. 0 to 23, right? 0, if you include 0, it will be 24.
Okay, gotcha. Yeah.
So you got the 24 elements with this thing. Now, if I have to convert this one dimension, it's a one dimensional because the one square braces you can see. Can I convert into the two dimensional? If I had to convert into two dimensional, what should be the size of the two dimensional array? What should be size of two dimensional array if I had to convert this one into two dimensional?
Oh, brackets.
Array one dot shape. The first shape is 24 because 24 elements are there. So if I had to convert into two dimensional, what is that? What did you say?
Times 2, comma 2.
Oh no, I wanted to
And
convert same numbers. I don't want to add any numbers. The existing matrix itself, I wanted to convert into the two dimensional. Okay, no adding new values. No new values.
yeah, it should be 2, comma 12.
2 comma 12, very good. And any other answers? Array 1 dot reshape. We can use the reshape function. You 2 comma 12 you mentioned, right? So 2 rows and 12 columns. 2 rows and 12 columns. So how many ways you can do it? So what did you consider? How did you tell like 2 by 12? How you're able to say by 2 by 12?
There were 24 values, so
Correct, you
2 rows
multiplication.
should be covered.
So
Yeah.
multiplication of the two elements should be equal to the 24 because you have the 24 elements. 2 multiplied with the 12 is a 24. So how many such kind of a multiples are possible? Maybe 12 by 2
6 and
also.
4.
Yeah, 6 and 4. Very good. So 12 by 2 is one thing. 12 rows and the two columns. And similarly 6 and 4. 6 by 4 matrix. And 4 by 6 also possible. And 8 by 3. 3 by 8. These are all possibilities. Right? Yeah. You can reshape into such a way that the multiplication of the both the numbers should be equal to the total size of the array. So what will happen if you do? array1 dot reshape of 6 by 3. What it will throw, what it will happen. The 6 multiplied by 3 is 18, but we have the 24 elements. It is not possible. It will throw an
That
error.
should
It will
give
throw
an
an error
error.
because cannot reshape of the size 24 into the shape of 6 by 3 because only 18 elements you can fit in 6 by 3. And what if I wanted to do 6 by 5? Well, 30 elements were there. Right? Same error you will get. Cannot reshape the size of 24 into 6 by 5. The number of diamonds should match. Similarly, what if you have to, if you don't know the number of rows, you wanted to take the 4 rows, but you don't know number of columns. Ideally, it's supposed to be 6, then 24. You keep the -1. The numpy will calculate the values. 4 multiplied with something dash should be equal to 24. What should be filled in the dash? That should be 6. That will be taken care. You will get a 6 by 4. And similarly, you do for the row as well. For example, take this as a -1 and keep the 6 here. This should be the 4 value, right? So it will calculate that 4 by 6. Don't give the both -1 because it will not work. Either of them should be there. Only one dimension should be unknown. If you give the both -1, it will give an error. At least specify one unknown dimension. All right. So similarly, can you create a three-dimensional? So we got to know how to create a two-dimensional. How to create a three-dimensional. Same array. Same array. I wanted to create a three-dimensional. 24 elements are there. What should be the shape? Multiplication of the three variables should be equal to 24. How many ways it is
Yeah.
possible?
2 into 6 into 2.
Yeah, 2 into 2 into 6 or 2 into 6 into 2. Anything. So it's a three-dimensional. So can you convert it into the four-dimensional? Is it right? Multiplication equal to 24. Yeah, in this way you can build, you can convert into any dimension you like. Of course, it should be valid. It should be valid. Doubts? Right. So now, so what else other operations we can do within this NumPy? Yeah. Addition, multiplication. Yes, right. So you can do all the things. So addition of the two arrays, multiplication of the two arrays. So let me do that. So I'll create a very simple one. So A comma B, two matrices were there with a one-dimensional. See how simple it is. A plus B. It is doing the element by element addition. A minus B A multiplied with B, all other arithmetic operations are possible. Even, yeah, this is for the element by element. So 1 with the 4, 2 with the 5, 3 with the 6. Suppose if you are looking for the matrix level of multiplication, anybody recall? What is the matrix multiplication? How to do the matrix multiplication?
Rows into column.
The rows into columns, right? Generally, you have the matrix, suppose say, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and with 2, 5, 6, 7, 8, 9, 10, 2, 3. It's a 3 by 3 and 3 by 3, right? So to do the matrix multiplication, so what is the criteria it should satisfy? Number of columns in the first matrix should match with number of rows in the second matrix. Then only the matrix multiplication is possible. Okay, suppose here you have the 2, 3, 4, the 4 number of rows. Still it is possible. 4 by 3, right? 4 by 3 and 3 by 3. The number of columns in the first matrix should match with the number of rows in the second matrix. Then only matrix multiplication is possible. Let us try to do this matrix multiplication. This entire row multiplied with this entire column element by element. 1 multiplied with the 2 plus 2 multiplied with 7 plus 3 multiplied with the 10. This is the first element in the final matrix. And same row with the second column. You'll get that value. Same row with the third column. You'll get the another value. And the second one, this one with this one with second one, this one with third one. And you will get same thing with this one, same thing, this one. Total what is 1, 2, 3, 4. 4 rows multiplied with 3 columns, which is equal to these two numbers. Without even multiplying, you can get to know what is the output matrix after multiplication, right? The first matrix row values, second matrix column values, if you take the both of them, that is my output shape. So that is eventually you will end up with the same size. Okay, without you don't need to do the calculations generally. So just for the you don't need to know, but I'm just giving as a the intuition how the matrix multiplication will work. So I'm not going to talk about all the everything is possible. Of course, trigonometric operations and the linear algebra operations we'll see one by one. So let me do that multiplication. I will take the matrix A, np dot a range of 1 to 10. Total how many values will be there? Total 9, right? 1 to 10. Total we have the 9. So I can reshape it to what? Reshape it to 3 by 3. 3 multiplied with 3. That is my matrix A. np dot a range of, I have the values from 1 to 13. Total 12 values will be there. I can reshape into 3 by 4. 3 by 3 matrix and 3 by 4 matrix. Now print A, print B. Now I will do the matrix multiplication, that is np dot a comma b. You can see the output. Output will be of shape 3 by 4. 3 by 4. Matrix multiplication happened between these two matrices. What else we can do in the linear algebra? It's a 2 by 3. I can convert into the transpose. What is the transpose? The rows into the column and columns into the rows. So this is a row, I will convert into the column. This is a row, convert into the column. It's a transpose. If it is A, we call it the A transpose. This will have 3 by 2, opposite. 2 by 3, you will get a 3 by 2. So transpose also possible within the NumPy. So I will take this matrix for the transpose. A dot T. So this is my input. The rows are converted into the columns. The next is uh, even it can do the matrix inverse. General inverse is very hard to do it, right? You have to find the determinant and then only should be possible. The inverse matrix has to be singular. Otherwise, you can't do the matrix. The inverse calculation is not part of our goal, but I'm just telling you, like it is also possible. You don't need to worry. Like general inverse calculation is very complicated. When the dimensional of the matrix is too much, like a two-dimensional with more numbers, if it is there, right, it is very difficult to find. So it is having that function also. Linear algebra dot inverse of a matrix. Okay, so just call linear algebra dot inverse and pass this entire matrix. It will convert into the inverse. Right. If the inverse is not possible, to throw an error. Inverse is I can't do it. Why? Because matrix is not singular. It's nothing to do with just for the mathematicians who just wanted to use this library. Even for them, it is convenient. Suppose 1, 2, 2, 2, 2. So for random numbers, I will give 2, 2, 4, 4. It's inverse is not possible here. To throw an error. Circular matrix. Okay, so and what else other operations we can do? So linear algebra, okay, it's possible. So even whatever you learn in the school days, in college days, almost everything we can do. And we can even do the trigonometric operations. What are the trigonometric operations? You can apply the sine theta, the cos theta, and all. So suppose we have the 20 elements in an array. You wanted to apply the sign for the all of them. You just call np.sign pass that array. So it will convert all the values into the sign. Same thing for the cos, or any cos is possible. And exponentials, this exponential is we use a lot. And the logarithmics, so these and all generally possible. Okay, suppose if you wanted to know what and all can be done, always you can take the help, and you wanted to learn about this np.linear algebra functionalities. Just take this, type within the help. Okay, it will give you entire documentation. Either you can even go with the Google Chrome. Here also you will find the same documentation. Instead of that one, here you can see all the matrix power, the decompositions, like the SVDs, singular value decompositions, the Cholesky, eigenvector calculations. These are all generally famous for the machine learning. In the SVM and all, people will use the SVD and eigenvectors to do the calculations. And determinant, and the matrix rank, and the inverse. So almost every single linear algebra functionality was present in this. Okay, so let's stop it here today. So the next class will continue with a little bit advanced things in the NumPy. Okay, any questions?
And share the recording or the notebook.
Yeah, notebooks will be shared. I just need to know your email IDs. Email IDs should be shared uh, to me. So either you can inform to the Rani, she will share it with me because I need all of them. I will add to a group so that everybody get an access. So whoever got confirmation, so they all get the recordings. I had to. Can we do the class a bit earlier? Also, do you record the? Yes, the videos will be recorded. Yes, this session will be 1 hour. I move it forward because now already the 7 a.m. batch was going on. Okay, so that in 1 week that gets over by my probably in the next 6 classes that gets over. Then I will move this class to 7 a.m. because I'm from India, right? Now I'm taking it to the 8 a.m. So I will move it to 7 a.m. But just tolerate with me for 1 week. After that I will move. Okay.
And today's session is recorded, right? Where do I find the recording?
So I had to get your this thing email ID. Then I will share to the Google Drive.
Okay, thank you.
Yeah.
Can I put that in the group?
I'm not there in the group.
Okay.
So you can ask the person, Rani. She will because I need to get confirmation. Once I get a confirmation,
Okay.
everybody mail IDs I will get. Those mail IDs I can forward all the recordings. Maybe we
Okay.
have the tomorrow or day after tomorrow. Please, yeah, 1 minute.